Hello and welcome to episode number 20 of our series on computer vision and deep learning with Python. In today's episode, I'm just going to whet your appetite and show you what is known as the hello world of computer vision. Usually, we have an idea that hello world is the easiest, simplest program you can write when you're getting started with any technology. And so when you are starting with deep learning, we also have something you do that is seen as the least you should be able to do when you get started with deep learning. And it has to do with recognizing characters that have been written by hand. Okay, so you are essentially going to train a deep learning model to recognize handwritten characters, and I have the code already written. The idea of this video is not to show you how, but I'm just going to show you what is possible even in a hello world program with deep learning. Okay, so I'm going to run it already. Let me run this. Okay, so I have run the program, and what you are seeing on the screen is the neural network is training itself and is printing out the errors it is making and then how much accurate it is. So you can see that I have about 95% accuracy and is making an error of about 0.145. I mean, these are all stuff that I'll teach you in this course. I would decipher all these things and then they will not seem like magic to you anymore. Okay, so while the network is training itself, let me go ahead and then show you how you can test this program on your own computer. So when you come to GitHub and you go to my GitHub page, that is Hackstock, you would see a repository called Deep OCR. What I'm trying to mean by the name of the repository is an OCR that is implemented using a deep neural network. Okay, so once you come to my GitHub page, that is github.com/hackstock/deep-OCR, you would see the code on GitHub. You can clone it, and once you have cloned it, I have detailed instruction on how to set it up. You can set it up using either Anaconda, is not required, but if you already have Anaconda installed on your computer, then this setup is going to be easy for you to do. Otherwise, if you have just normal Python installed on your computer, then you can create a virtual environment and install the dependencies that are used in implementing the project, and you'll be able to play with it. Okay, so I'm sure by now it has finished training itself. Yeah, so the idea of this project is to let the computer try to guess, and it's important that you get the words I'm using very well. I am saying try to guess because it is very difficult to try to build a neural network that is perfect. No matter what you do, there is going to be an error rate, but then once it is accurate to a certain level, once the accuracy of the network is satisfactory, then it is okay to use it, knowing that it will make some errors. Okay, so you make provisions for that. That is why when you speak to statisticians, they usually speak in terms of probabilities so that you are not surprised if what they said doesn't happen. Okay, so from the terminal you can see that I trained this neural network on a data set 14 times. I actually told it to train itself 50 times, but then in the code I have something that tells it to stop training itself once it sees that the accuracy and the error rate are not improving after 2 steps. So I think when it got to the 14th time, it realized that it is not improving any further. So it is okay enough. Okay, so this is the whole idea. I have trained this neural network using a data set that is usually used for Hello World in Deep Learning. It is called MNIST, and is a set of 70,000 images representing handwritten digits. So they made people from all walks of life, people with different handwritings. They made these people write the digits from 0 to 9, okay, so that they could capture the different ways in which different people write these characters. And they have given us this data set free of charge. It is part of Keras. And so in Keras, I got access to the MNIST data set, and I trained my neural network using 60,000 handwritten images, okay? And now I am going to write on this canvas, the black section of the canvas, and then the computer is going to try to tell me what I was writing. So when it does that, you see the output in the console here. Okay, so let's try one and see. Now, because I'm using OpenCV, I need to press some keys to let this window know when I'm ready to write. For example, if I press Q, then the window will go away. If I press S, then I'm trying to draw, because I'm going to draw with my mouse, and this window is listening for a lot of mouse events, so I need to let it know when I'm ready to draw a character by pressing S on my keyboard. And when I press C, it will clear the character so that I can draw a new one, and it will make prediction on that. So let's start with let me try to so you see, when I do this, I am drawing the character, okay? I'm moving my mouse and it's drawing a character. Now when I release the mouse, then I am done with my character. Then I can press P to make the prediction, but obviously this is no character, no digit, so I'm going to press C to clear it, okay? And then I'm going to press S to start drawing again. And now I'm going to try to draw something that looks like a 4, okay? So I draw 4 and I press P to predict, and you can see here the neural network predicted that I was trying to draw a 4, okay? So I'm going to press C to clear, and then let's test another character. I'm going to draw a 1, and let's see what it predicts. So you see, I told you it is not free from errors. It does make errors, okay? And the whole idea is for you to get to know what is possible, okay? But there are architectures we can implement to actually improve this so that we can get 1 easily. But I mean, this is just an appetizer. So let's try another character. What character can I try? Let's try something like a 2. And it thinks the 2 is also 7. This is performing pretty bad, okay? So let me quit this, and then I will retrain it again, then we'll see. Okay. Before I do the training, let me open the code so that I can show you certain things as well. So let me go to full screen here. Let me close this. Okay, and let me start the code again. Whilst it is training itself, I'm going to explain to you how this thing works. So like I said, I made use of the Keras deep learning library, and I use it to train a model. I spoke of MNIST. This is a data set that is shipped free of charge with the Keras and many other deep learning libraries out there, okay? And before you do deep learning, you need to do something called data pre-processing, and I did pre-processing over here where you scale your features and you normalize. And once again, the essence of this video is not for you to understand how to build these models. It is just to show you what is possible and what to expect, okay? So this here is a very simple model I built. I have a deep network with 512 on the first, 512 nodes on the first hidden layer, and I have 256 nodes on the second hidden layer, and I have 10 nodes on the output layer, and I've defined some activation functions, and I do my training here where I fit it to the training images and then their expected output, and I'm able to make predictions on them. Now when you come to this app file, what I'm doing here is I have this mouse hook that is called anytime I move my mouse on the window. Anytime I move my mouse on the OpenCV window, and what happens is when I move the mouse, it records the XY point of my mouse pointer, and I draw a line between that. So as I move, I'll be drawing lines between the previous and the most recent point. And these are the keys I was talking about. When I press Q, it quits. When I press S, it means I'm going to start drawing. When I press C, I clear the screen, and I make it possible for you to draw again. And when I press P, I try to do a prediction with a neural network. Okay, so up here, I created an instance of the neural network, which is defined in this model file. Okay, so hopefully our training is done, and whoa, it did this on the 10th. Okay, so let's see. I'm going to try to draw a 1. Okay, it looks like this training is much better than what it did in the previous one. So it's telling me this is a 1. Okay, let me clear the screen, and then I'll try to draw. Sorry, this is a bad thing that happened. So I'm going to clear the screen, and I'll try to draw something like 2. Let's predict. Oh, nice. So it looks like the second time we try this is behaving well. Okay, and there's also a flaw in my implementation. The perfect way to do this is you try what is known as hyperparameter tuning, where you tune how your network operates, and when you get the best predictions, when you get the best performance from your neural network, you export what it has learned, and in the form of a file containing weight. Okay, and so what I can do to improve this is I save the model when it is at its peak performance, best performance. I save its weight, and so that I don't have to do this training all the time. That way my network becomes predictable, and I know what it can do and what it cannot do. But like I said, this is just the hello world into deep learning, so I don't really care how it's performing right now, but I just want to make you aware of the vision for this series of videos. These are what we are going to be doing, and this is the hello world, so you can imagine when we begin to do more wonderful things. Okay, let me clear this. Let's try another character. Let's say 4. I don't know who writes a 4 like this. Okay, it got that one also correct. Let's try another character. What haven't we tried? Let's say 7. Whoa, it looks like this network is really performing well. I want it to fail, and then you would know that it is not perfect. Okay, so let's try, what character haven't I tried? Let's try 9. Yeah, so you see it is failing here. It is thinking that 9 is a 1. Let's try another one. Hopefully it will fail. And the reason I'm saying hopefully it will fail is not because deep learning is not that powerful. It is because this is a very simple model, and I don't expect it to perform so well. Okay, so it got the 0 also. Now, in case all this sounds like magic to you, it is really not magic. Okay, it is really not magic. Deep learning is all about exposing a neural network into a lot of data. You expose a lot of data to your neural network, and your neural network does what is known as generalization. So it discovers patterns in the data that you don't have to teach it. That is the difference between deep learning and classical machine learning. In classical machine learning, you have to make an attempt, you have to do feature engineering, you have to select features of your data that you think are interesting and that you think the algorithm should base their learning on. But for deep learning, you don't have to do feature engineering. You just have to throw a lot of data that doesn't have class imbalance. And when I say class imbalance, I mean the different number of digits should match. So if I have thousand of images showing 1, I should have thousand of images showing 2, 3, and so on up to 9. Okay. And recognizing digits is something so simple for humans to do. It is so simple we don't even think about it. In fact, it is not just about recognizing digits. Recognizing anything or identifying anything we see is so simple a task that we don't think about it. But the truth is, even psychologists cannot explain to you how human beings see. Yes, they can tell you about the human visual cortex system, where the eye sends signals to the brain and the brain does interpretations. But as to the step-by-step operations that goes on for your brain to even form the image, I mean, it is hard for humans to explain, even though it is so easy for us to do. Okay, and when it comes to deep learning, we try to teach the computer to learn the same way human beings learn. So for instance, the way we learn how to speak when we are children is we listen to our parents. Mention words and say a lot of things so many times, and then we start saying them, we make mistakes, and then our parents will correct us, and we are exposed to a lot more different words later. Nobody has to teach us how to construct sentences that are syntactically correct or semantically correct, but we learn this over time, and it appears so simple that we don't think about it, but it is something complex. Okay, when it comes to deep learning, we try to mimic the way the human brain works. So when I look at an image, or when you look at an image, you easily identify what is in the image. You can be able to describe the content of the image. Unfortunately, when a computer looks like at an image, all it sees is a multi-dimensional array of pixel values. If you have watched all the videos from video 1 up to now, you know that all that we have been doing, all the manipulations we have been doing in images, has to do with mathematical operations on multi-dimensional array of numbers. Okay, that is what a computer sees, and this is what we call a semantic gap. There is a gap between how humans interpret content of videos or images, and how computers interpret them. As far as the computer is concerned, it has no idea that this image contains a 0 or 1. But as we expose the neural network to these 60,000 handwritten digits, the neural network is able to pick a pattern in the images. And for your information, the reason why I write on a black background is because the training data, the images I used to train the neural network, were also written with white ink on a black background. Okay, that is how it has been pre-post processed to look like. So if I give this thing something on a different background written with a different color, the output is going to be shady. It is going to be something very, very useless. Okay, for instance, let me demo that once again. So I press S and then I draw something very useless on this. The neural network will just make its best guess, but you would know that it is very, very wrong. So if I do this and I press P, see, it says it's an 8. Meanwhile, this is not an 8 in any way. But the way it is working is that once we expose it to a lot of data, it picks up patterns. It knows that when you write 1, there is a string of white pixels aligned vertically. When you write 0, there are a circular path filled with white zeros. Okay, that is the same way we learn as humans being as human beings, and that is how we are teaching neural networks to operate. So like I said, this is just an appetizer. It is a teaser. It's just to whet your interest, okay, whet your appetite, so that you'll be more interested. And like I said, this is just a hello world. So once I begin to teach you how to build neural networks and how to train neural networks, this is what we are going to do for our hello world, and we will improve it over time so that it will recognize it will be better at recognizing hand-drawn characters. Okay, and if you are somebody who is into robotics, playing with maker boards like Arduino, Raspberry Pis, basically if you like to build things yourself, this opens up a a big door for you. Okay, just imagine now that you have been able to train a neural network to identify hand-drawn characters. What can you build with this? You can build an app on your phone where I draw 1 to turn on the light in my room, I draw 0 to turn it off. You get a point. Any interface that requires that you punch in a pin, you can now replace it with a touch device where I would actually write the code, and then the neural network will recognize the pin that I'm entering, and it will pass it to whatever authentication system you are building. So it's like it's helping you to let humans interact with computers in a more natural way, in a modern way, in a nicer way. Okay, so it doesn't end when you are able to recognize characters, but I mean, just imagine, as you've been able to do this, you can train another neural network that does text to speech translation, so that you can actually write, and then your neural network will recognize your handwriting, and then it will pass whatever you've written to the text to speech engine, and the text to speech engine is going to read it out for you loud. Okay, so just imagine the tools you can build to help blind people, just like, I mean, the visually impaired people, and all the wonderful things that you can do. So when it comes to deep learning, the limit is only your imagination, and this is what makes it very interesting for me. So I hope you will keep watching this channel and share, subscribe, and watch out for when I start releasing videos on deep learning. For now, I want you to understand how to do some basic image manipulations, and then we can launch fully into deep learning. Okay, so thank you for watching. Leave your comment, don't forget to subscribe, share, and I'll see you in the next video.